In 1970, John Crane was awarded the patent for the first spiral groove dry gas seal. With over 50 years of operational success, our dry gas seals are chosen by customers around the world in a wide range of applications, supporting reliable, efficient, and sustainable operations. Each feature of our dry gas seals plays a role in reducing contact, minimizing wear, and helping extend seal life, supporting more stable, reliable operation. Dry gas seals use two seal faces, a rotating seat, also known as the mating ring, and a stationary face, the primary ring. As the mating ring rotates, gas is drawn into the spiral grooves, building pressure and creating hydrodynamic lift. That lift separates the seal faces, enabling non-contacting operation, reducing friction, limiting wear and protecting critical equipment. John Crane's logarithmic spiral groove design is optimized with a groove angle to generate maximum lift. This helps customers maintain reliable sealing performance during normal operation and process changes. Here's how that separation is created. The rotating seat contains spiral grooves that guide process gas across the sealing interface. As the gas moves through the groove pattern, pressure builds towards the end of the groove and separates the faces. That pressure maintains a thin film between the rotating and stationary faces, enabling stable, non-contacting operation. The result is reliable non-contacting sealing performance that helps protect critical equipment, reduce maintenance demands, and support long-term uptime. The Type 28 dry gas seal revolutionized sealing technology, and we continue that innovation journey today, solving our customers' sealing challenges and shaping tomorrow's possibilities, because engineering a better future starts here.